Hello, my name is Grace Topol, and I'm going to be describing what happened during the TLC drug testing experiment. To start off for this experiment, let me describe the procedures that we went through and the processes that we took in order to analyze the drug samples. We ended up analyzing a total of 6 drug samples, about 20 milligrams of each. They were Benadryl, aspirin, Tylenol, ibuprofen, caffeine, and Excedrin, which is a combination of aspirin and caffeine. Each of these drugs was placed into its own test tube, and then added to the tube was 2 milliliters of methanol. Methanol was used to dissolve 20 milligrams of each drug in their respective tubes separately. These tubes were then closed and shaked so that way the drug would be able to dissolve a lot better. They weren't able to dissolve fully in the time of the experiment, but they were able to dissolve enough in order to conduct the experiment properly. For the developing chamber for these thin layer chromatography plates, or TLC plates, a beaker was used and 5 milliliters of methanol was added to the bottom of the beaker, and it was then covered with a lid so that way the methanol would not evaporate. And this created the development chamber for the plates. Now, the TLC plates, there were 2 of them, and each one held 3 drug samples on it. I'm going to be calling them the bat plate and the ice plate. Now, on the bat plate, it was testing Benadryl, aspirin, and Tylenol. The ice plate held ibuprofen, caffeine, and Excedrin. These plates were prepped by first drawing a line in pencil very lightly, about 1 centimeter from the bottom of the plate and 1 centimeter from the top of the plate. The bottom line indicated the start line, and the top line indicated the furthest that we wanted to let the liquid travel, if it was still traveling, and it didn't stop on its own. So these plates were each prepped with 3 concentrated drops of each drug. The way we did that is, for example, when I was testing the Benadryl, I used a pipette, and I took the pipette and I sucked up a little bit of the methanol Benadryl mixture that was in there. And I took it out and I dropped 1 drop on the start line and towards the edge of the plate. I waited for that then to air dry fully, and then I would apply another drop to that exact same spot to further concentrate it, and then repeat it, let that air dry, and then repeat this 1 more time of dropping and air drying. This process was repeated using the methanol drug liquid for each of the spots on both of the plates. So the bat plate and the ice plate each had 3 spots of concentrated drug sample basically on each of the plates. With that, at once the bat plate was prepped, since each one of these plates was prepped separately, the bat plate was then put into the developing chamber with the side with the drops being placed in the actual layer of methanol at the bottom, and then it was covered once again and left to develop. During this time, the methanol was absorbed into the TLC plate, so that way we could see it traveling up the plate. At this time, while the bat plate was developing, the ice plate was prepped using the same method as the bat plate, so the 3 concentrated drops onto the ice plate. The bat plate, it did not reach the top line of the TLC plate. It stopped at around 5.3 centimeters. So 5.3 centimeters from the bottom of the plate all the way to the top of the plate, or 5.3 from the start line to where it stopped eventually. So that was about how far that it traveled. The ice plate was then, and once the bat plate was removed, it was left to air dry, and the ice plate was placed into the developing chamber with a little bit more methanol in the bottom, so that way it could absorb properly, and it was covered and left to develop, and the bat plate was dried. By the time that the ice plate, it did absorb all the way to the top line that was drawn, so it was removed and allowed to air dry as well. When both of them were air dried, I used the orange goggles and the black light over the plates in order to see how far the drugs had traveled up the actual plate in order to calculate the retention factor value. So that's the RF value. That is basically telling me how polar the drug is in relation to the solvent, and it gives me some information about the drug. So to summarize, as the results, all of the dots that showed up in kind of a bluish purplish color underneath the light. Of course, there was a little bit of an orange tint as well to it due to the glasses, but it was mostly a bluish purple in a way. For Benadryl did not actually show up at all. It was not present on the plate. I didn't see any dot even at the start. This could be due to the fact that Benadryl, the tablet that it came in, was one of those almost plastic-looking coated tablets, and so the drug is inside of the casing, and the methanol most likely did not penetrate all the way through the casing to actually release the drug into the methanol. So that was probably an area of error in this particular experiment, since the procedures do not dictate it to break open the tablet just to dissolve the tablet necessarily using the methanol. So Benadryl did not show up at all under the black light, making for the retention factor to actually equal 0 because it didn't show up. Now with aspirin though, aspirin traveled about 5 centimeters. So it traveled from the start to nearly the top of that top line, basically, the top of where the methanol stopped traveling. So it traveled 5 centimeters up there, and it created quite a bit of a large spot on there. Along with that, then the last one on there, Tylenol. Tylenol didn't have as big of a spot as the aspirin did, but it did still travel quite a ways. It traveled about 4.2 centimeters up the plate. Now on the ice plate, ibuprofen did not travel far at all. It traveled about 0.2 centimeters, so it did leave the line a little bit. There was a dot still present, but that led to a very small RF factor of 0.04, since the total distance that the solvent traveled on the ice plate was 5.6 centimeters, all the way up to the top line that was drawn. Caffeine traveled very far. It traveled 5.5 centimeters up the plate, leading to an RF factor of 0.98. And Excedrin also, much like Tylenol, traveled not as far as caffeine, but it did travel quite a ways still. It traveled 4.8 centimeters, leading to an RF factor of 0.86. And I don't believe that I mentioned the RF factors for aspirin and Tylenol. I believe I skipped over those, but the RF factor for aspirin was 0.94 since it traveled so far, and Tylenol was 0.79 since it didn't travel quite as far. The spots for caffeine and Excedrin also were quite large. Caffeine was probably the largest dot that was seen out of both of the plates. And Excedrin actually created kind of this oblong shape on there. And this is probably because it was almost too concentrated on the spot. So it left more of a streak rather than a spot whenever it traveled. So that was the processes that were used along with the results that were gathered from the testing. Now, in order to go a little further to explain certain portions of this testing, it's important to understand what exactly a mobile phase and a stationary phase are in terms of this experiment, since that is really what we're using in order to determine this information for these drugs. So the mobile phase used in this experiment is methanol, and that is the part that was moving the drugs. The stationary phase, though, was the plate material of the TLC plates, and usually it's either silica or alumina. Now, this is important because the solubility in the mobile phase and attraction to the stationary phase affect how far the samples travel. So for instance, as evidenced by some of these results, ibuprofen had a very high affinity for the stationary phase. So it was stuck on that spot and it was sucked into there. But it did not have a very high attraction for the mobile phase, so it did not move at all. Meanwhile, though, caffeine did present that it was very soluble in the mobile phase, but not very attracted to the stationary phase. So it was able to freely move up the TLC plate. So this is why those two things are important to understand whenever doing TLC testing. The mobile phase and the stationary phase have a great effect on how far your samples are going to move based on the polarity of your samples and how soluble they are in the mobile phase. Now, the RF is calculated by dividing the distance the sample traveled by the distance that the solvent traveled. So by taking basically the measurement of 5, since aspirin traveled 5 centimeters, for example, and dividing it by 5.3 centimeters, which is the full distance that the solvent ended up traveling, we get the value of 0.94. This is, of course, rounded using scientific figures. Now, the RF factor, though, plays a very important role since it helps to identify the compound, and it does provide information about how polar it is. So if it has a higher RF value, it has a higher polarity. Those two things go together. And now, the last thing to understand really about TLC testing of drugs is, why is this a presumptive test and not a confirmatory test? If it provides you so much information about the polarity of the drug and its makeup, why is it not confirmatory? It's a presumptive test because it only really confirms the possibility of a certain substance being present in whatever was being tested, in the substance. It only confirms the presence of an analyte. And this also is dependent on your mobile phase. Did your mobile phase destroy the actual target analyte that you were looking for, or some important part of the drug, and so it's reading as something different? Or did the mobile phase just proceed to dissolve it and then move it up the plate without altering it in any meaningful way for the testing? It's also possible for two different substances to have the same RF values, but still be very different. For example, if we look at the results here, we can see that both aspirin and caffeine moved quite far up the chart, but they're both very different substances. We have a RF value, though, of 0.94 and 0.98. These are very different substances, one being a depressant and the other one being a stimulant, but they have very similar RF values. So as you can see, we can't necessarily go by just the RF values to determine the identity of a drug. We have to follow up with some other testing that is going to give us some real insight into the actual makeup of what it is that we are testing, rather than just going by how far it travels of a plate and what color and size the spot is. So thank you so much for listening to my presentation on the results of this experiment and information on the TLC testing.